Today I'll be going over how to do the atom quiz. So part A says the average atomic mass of naturally occurring neon is 20.18 mu. There are two common isotopes of naturally occurring neon as indicated in the table below. So we have the isotope neon 20 and the isotope neon 22 with the corresponding masses. First, we're asked, using the information above, calculate the percent abundance of each isotope. So what we do here is take the masses of each isotope and we add them up, taking into account for the percent that we need to find, and we represent that using x, and we basically just solve for x, and we get that x is 0.905, and we convert that into a percent, which is 90.5% for neon 20, and we have that neon 22 is 9.5%. Part 2 says calculate the number of neon 22 atoms in a 12.55 gram sample of a naturally occurring neon. And here we just do stoichiometry. We go from the grams given to us and we convert them to atoms, and we do that by dividing by the molar mass, and then we multiply by the moles, which is here, the percent, and then we multiply by Avogadro's number, and we get that neon 22 is 3.6 times 10 to the 22 molecules. Part B says a major line in the emission spectrum of neon corresponds to a frequency of 4.34 times 10 to the 14th. Calculate the wavelength in nanometers of the light corresponds to this line. So we use the equation C equals wavelength times V, and then we rearrange this to find the wavelength. And so we plug in the numbers, the corresponding numbers. So it would be the constant number of C over our given frequency, and we multiply that or divide that by 10 to the negative 9 to convert the number to nanometers, and we get that it's 690 nanometers. Part C says in the upper atmosphere, ozone molecules decompose as they absorb ultraviolet radiation, as shown by the equation below. Ozone serves to block harmful ultraviolet radiation that comes from the sun, and here's our equation. And we're given that a molecule of O3 absorbs a photon with the frequency of 1 times 10 to the negative 15. Part 1 asks us how much energy in joules does the O3 molecule absorb per photon, and here we use the equation E equals HV. And again, we plug in the numbers, the constant 6.63 times 10 to the negative 34 times our given value, and we find that E equals 6.63 times 10 to the negative 19 joules. Part C says the minimum energy needed to break an oxygen-oxygen bond in the ozone is 387 kilojoules per mole. Does a photon with a frequency of 1 times 10 to the negative or to the 15 have enough energy to break this bond? And so here we use stoichiometry. We multiply the number we got here times Avogadro's number, then divide by 1000 to convert it into kilojoules, and we get that 399 kilojoules, and 399 kilojoules is greater than 387 kilojoules, so the bond can be broken. And that's it for the atom quiz.